Hello, everybody. This is Abdullah, and this is my partner Bring. And today we are talking about our project, self-driving car simulation. So in this presentation, we're going to talk about the introduction of the selected system, and then we're going to dive into the architecture. After that, we are going to show the proposed new changes to the system that we chose. After that, we're gonna talk about the architecture of the proposed system. Then we're gonna show some demonstration videos and a demonstration on the simulation software. And then the last thing we're gonna show is the lessons learned from this project. So as we know, there are a lot of fatalities that happen because of drunk driving. Uh, and then a study shows that actually 10,000 traffic fatalities are caused by drunken driving every year. Uh, so self-driving is a very self-driving will be a useful system to reduce fatalities that happen because of on this for the self-driving system. We used different software to simulate to be able to simulate it on Carla and GTA V, like CV2 and YOLO 7. As you can see here, this is the study that I was talking about. The year, you can see the year on the left hand side of the table. The study has been done from 2016 to 2019. As we can see, every year there's an average of 30,000 total traffic fatalities, and 10,000 of these are actually caused by or related to alcohol.
This is the software architecture for our project. So first we have the hardware and the software on the car, and this is going to be autonomous controller, which have two duty. Is have the adaptive cruise control and the lane keep assistant. For the adaptive cruise control, we can use a radar that to estimate the distance between our car and the car in front of us. But for the lane keep assistant, we can use the camera to as an input to see the lane by using the Hawk transform. Anyway, when we have the data and then we generate the data to the car control, and then the car can see the object in the front, and the car can see detect the lane, and then the car can send the data to the accelerate and decelerate. Accelerate just like make the car move forward. Decelerate just brake, just move the just make the car slow down or stop, and steer like steer to the left or to the right of the lane. So this process is have to work simultaneously with the input sensor, just like a millisecond. Every time that is have the data, it's gonna keep moving the car to the left, to the right, or slow, faster. And we have the human here because this is not like a full self driving. We have the human driver to interact with the software, and then we have the control button to override the program in case of something wrong, and then we can override. And anyway, this software cannot be trained itself, so the data have to send back to the main server in the cloud system every day, and then in that cloud system it have the GPU to train the model that we have in each day the incident that we have, something like when did the human override the car, and then we need to know what happened 15 seconds before or 15 seconds after that, how did the human operate the car. Okay, however, that is like the concept that we cannot implement in our project. So I remove the radar out from the input sensor, and then we rely on the camera, because in the real world we cannot install every hardware like every autonomous controller in specific car with the radar. We need to install this hardware into every car, so we need to remove the radar, and we try to figure out how to detect the object in front of us. And then we found out that we can use YOLO V7 to detect the object in front of us and behind us by using only the camera, just like a Tesla vision. Okay, so we remove the input sensor from here. So we implement our project from the real world footage. So I just record this video for my car from the front camera and the back camera. The front camera just record the object that coming, like the incoming traffic or the way that we go, and the back camera just record the car that behind us. So in the future, maybe we can use occupancy neural network to generate the car in 3D form, like the car on the road, which means the object on the road into 3D form, and we can estimate the distance by using the time series like I and N. Okay, anyway, this is the first step. We can see we can see the accuracy of the car, like it's 96%. This one is 95% because we can see full body of the car. We use the pre-trained model in the YOLO V7 to see all these objects, and then we just put it here. The reason that we use YOLO 7, this can detect multiple objects. And this is the way that we detect the object. We cannot detect the lane by using this one. So we use the Hawk transform and the candy. The next one we use first we use the ROI, like a region of the interest, to eliminate unwanted area. We don't want this area. We don't want the sky. We don't want to see the sky because it have nothing to do with the sky. We just want to see the line on the road. So we just eliminate the ROI. And then we can see the road here, the lane of the road here. Or we want to see just only the lane of the road. So we can generate the data into canny air detection, which is here. Okay, here is the way that I see the object. So you can see like if we have too much sky here, we can't see anything. We can, it's have a lot of noise. So you can see the white line here. So we can see the white line here. We can't see anything. So we need to make the angle to be this angle. So we can see the green. Okay. So you can see this one. It can detect the line here. We use a Hawk transform to detect the diagonal line, which this one and this one. So we generate the line here to be the green line in here to show the road, and then we can put the car in the center of the road, which is the next phase. But that we don't have that much time to do it.
So for the lesson learned, as you can see, we have two lessons learned. First, from this self-driving simulator world, we figured out that detecting the lanes are quite different from real world data. In Kala, we can detect those objects easily, but in GTA V, which is the game that we simulated the system on, the object and lanes are hard to detect because we need visualization via canny edge detection and half transform. We need to adjust several times to get the result on the half transform to get the two lines on the road. So we were varying different things, and were hard to get these lanes because, as we mentioned, we need more visualization. The second lesson learned is that detecting objects in the car. First, we used the CNN model to detect the object, which was too slow for us. So we spent a few days to figure out that the best method to detect the objects on the road is using a deep learning model, which consists of YOLO, and that gives us a faster method to detect the object, as you saw in the demonstration video. And that's all. Thank you.
Okay, thank you for listening us.